Oh, hey, you're still here. Great. This is the modified George Atwood's machine. So it's actually easier than the last one, and I'm just going to get you guys started. I am not going through the whole thing. Here's just to get you started. Use physics words to describe the motion. Well, what's going to happen here? I've got this mass 1 is going to be accelerated to the left. Is that left? No, that's right. Start video over. Take two. Okay, mass 1 is being accelerated to the right. Mass 2 is going to be accelerated downwards. So I have two different accelerations here. It looks like this acceleration is going around the corner like that. I'm probably going to call all of that positive. Yeah, okay, good. Great start, everybody. Fantastic job. Draw a free body diagram for each of the masses. Okay, gosh, you should really be able to do this on your own, but I'm going to help you out. So this one on the cart, I'm going to say, okay, well, it's on a surface, so I know I have normal force going up, Fn. It is on Earth. I have force of gravity going down. And then it has tension in the string because it's being pulled along here. It has some kind of force of tension. Now for mass 2, it has a force of tension up, which will be the same length as this first force of tension. So I need to make that a little bit bigger, I guess. That's about the same size. And then I have my mass 2, Fg of mass 2. I'm going to call that Fg1. This is Fg2 of mass 2. Boom! Free body diagram, FBD. All finished. Okay. Determine which way is accelerating. Make that way positive. All right, it's going to be accelerating around this way. I'm going to make that way positive. I'm going to give myself an A+, so I know it's accelerating positive around that way. Except I'm going to make it a small a, because really that's acceleration. Let's see. Do the sum of all forces equal 0? Heavens, no. It's accelerating. No. What do the sum of, if not, what does sum of all forces equal to? Okay, so this is the tricky part. Now, my M1, it has a, let's do that thing where I did it in the last video where I had M1 here. It was different in the last video a little bit, but and then like M1's being pulled by this mass 2. And if we were to look at it like linearly, well, it's accelerating that way, and I can treat it as it is in a line. And so if I'm accelerating this way, well, I have to really look at the sum of all forces in the x direction and the sum of all forces in the y direction. So just for your fun, I'm going to set up my axes. This is going to be my positive y. This is going to be my x. So here in the x direction, let's see what's happening when I straighten this all out. So M2 is pulling downwards, right? So really, the FGM2, if I was to put it this way, I'm not going to put it this way. Let's do it straight on the diagram. But we can treat it like this. So let's do it on the diagram. So now this FG of M2 is pulling down, correct? So I have FG2 pulling down. This FG1 over here is not resisting this FG2 at all. In fact, it's balanced here with the normal force. And then here on the FG2, I have a force of tension. And then I also have this force of tension here, Ft. So if I looked at the sum of all forces in the x direction, well, the sum of all forces in the x direction are not equal to 0. The sum of all forces in the x direction are going to be equal to, let's see, I've got Fg2. Remember we said this direction is positive A. Give myself an A+. This Fg2 here, so I'm going to go Fg2. Let's see, the Ft is going against the acceleration plus, so that means a minus Ft. And then I have this Ft right here, which is going in the positive direction, so it's plus Ft. Oh my goodness, look what happens again. The FTs cancel out. Sweet. The sum of all forces is in the x direction is just Fg2. Well, that makes sense. The only thing that's accelerating this is the mass 2 and Fg2. So this force of gravity on M1 is not accelerating it. If we cut that tension, it would just be sitting there. But now I've got just this Fg2 is accelerating it. Okay? Sum of all forces in the y direction, well, that's going to be equal to Fn minus Fg1 which are equal, so that's going to be equal to 0. So actually the sum of all forces in the y direction are equal to 0. So the only force that I need to worry about is this Fg2. That's the only force that's accelerating the system. The sum of all forces, well, I know the sum of all forces in the x direction are going to be equal to mass times acceleration. We said that the only force that's accelerating it is Fg2 is equal to the mass of the system. Don't forget that it's mass of the system, not just one mass. It's not just at mass 2, and that times acceleration. And I think you can finish off the rest of this without my help. Thanks a lot for tuning in, and I look forward to seeing your learning.